We're going to take this refrigerator off the grid. The Samsung 24 cubic foot refrigerator, which draws about 240 watts, 5 amps, suffers no ill effects because it is hooked up to an EcoFlow Delta 2 Max. As we can see from the indicator, we have about 11 hours of power remaining on this unit. It's drawing currently 172 watts. In our area, most of our power outages average in the minutes to the low hours. So having coverage for 10 to 11 hours is plenty at this point. But it begs the question, what happens when that EcoFlow runs out of power? In this particular home, we have at least two choices. We can use the Prius hybrid engine to run a DC to AC inverter to apply power to run the refrigerator. Likewise, we can utilize the power of this Chevy Bolt EUV to charge the EcoFlow or to run that DC to AC inverter. Regardless of which vehicle is using the DC to AC inverter, I can plug in my EcoFlow and charge off of that, or I can use the adapter provided by the EcoFlow to run off the 12-volt power port located in the vehicle. Both of these solutions supply a very low charge rate, so there's got to be a better solution. One of the interesting things about the EcoFlow is that you can get higher current into it by simply connecting solar panels, which begs the question, what if we could trick the EcoFlow into thinking that it was connected to a solar panel and providing that higher DC current? That's where a device like the Pecron smart car charger, DC 12 to 42 volts, can come in handy. In this video, we're going to learn how to tap into the automotive 12-volt system, then step up that voltage so that when we feed it into the EcoFlow, it thinks it's getting power from a solar panel, thus allowing it to charge much faster than if it was just connected to the 12-volt battery of the vehicle. When working with wiring, it's always great to know which is positive and which is negative, and most of our cables indicate that with red or black. Pecron decided to go with all black. Fortunately, they did label the positive and negative cable for us, though it would have been easier if they would have gone with a color. In order to get power from the vehicle, we'll need cable that provides lugs to the battery of the appropriate size, and we will need an XT60 connector, which will feed into the input connector. Hold on, this is an XT90 connector, while this is an XT60 connector, and while this will fit the EcoFlow, it won't work here, which gives us a bit of a dilemma until I realized that the Pecron comes with this huge harness. Now this harness has lugs on one end so that you can connect it to your battery, and on this end is a fuse, and then finally we have an XT90 which will feed right into the Pecron. So for my purposes, I need this connector and part of this harness so I can cut this cable, add an Anderson connector, which will then mate on either one of the vehicles. Now, while technically you could utilize the Pecron harness, after all, you get the battery lugs, it's fused, and then it goes right to the connector and it's all nicely built. The problem, of course, is just it's a lot of cable to deal with and that you're gonna have to bury somewhere in the vehicle. I'm just thankful that after I cut the cable, I only have to deal with mating into another Anderson connector. On the output side, the Pecron utilizes MC4 male and female connectors. To finally connect to our EcoFlow, we will need matching MC4 connectors that take us out to an XT60i connector, which will directly fit the EcoFlow. Make sure it is 60i, which includes this pin here in the center. If you use an XT60, it will not provide you with the higher charging rate. I previously wired a harness into our Prius with fuse and Anderson connector. There should be a description of that up here somewhere. Anyway, this allows us to easily connect the inverter to the vehicle so that we can easily convert DC to AC. I've done the same thing with the Chevy Bolt. I'll also provide a link for that configuration. This means that we can utilize the Anderson connector in either vehicle to connect to the Pecron. Of course, this means removing the lugs off the cable and providing an Anderson connector. With the EcoFlow Delta 2 Max having 3 different ways of being recharged, let's get some real-world numbers so that we can compare. Right now, we are plugged into a 120 circuit, and we see that we are at 68% charge, and we are drawing 1,654 watts of input. With the EcoFlow now plugged into the 12-volt system of the car, which is why we hear the chimes in the background, we are drawing 100 watts of input. It's going to take 8 hours to recharge this battery at that rate. Now we're ready to proceed with the installation. I've attached a cutting board to the Pecron just so that it has something nice to sit on, and it also has a little space underneath it for some ventilation. Got the cutting board at one of those dollar type stores. Originally I was gonna let it sit over here, you know, plastic on plastic, not metal or wood. And I decided I want it on that side of the hood. So now I need to measure out how much of the harness I'm going to keep and how much I'm going to cut off. This is the Anderson connector that I use for the inverters. So I need a new connector that I'm going to attach to this part of the harness, and that will mate. So this is about the right length. I wrap some electrical tape, then I cut the sleeve, pull the sleeve back, wrap electrical tape around that sleeve so it doesn't unravel, because they did a really nice job with that. So now we have 2 cables here. We have our black and red, and snip, and snip. So now we're really committed to the project, aren't we? Now we just have to strip off the insulation. So I grab one of the pins from the Anderson connector and I slide it over. And then I mark that both on the red and the black. And this is 10 millimeter wire that they provide, which is 8 gauge American. And I'm just going to use a wire stripper, and it's not meant for the amount of wire that I need to strip off, but I just move the guide out of the way, and let's see if we can get it on the first try. Yes, we did. Perfect. Okay, so I put it in here, and I love this wire stripper because all you have to worry about is how much insulation you want to strip off, and it'll do the cut without damaging the strands, which is what you want. So I give it a little twist so they're nicely knotted. And what we're going to do now is we're going to put the Anderson on. I'll probably put some heat shrink tubing over this first, but then I will put the Anderson on, and then I'll just crimp this with a crimping tool. This is the hydraulic crimping tool that we're using, and it's available online. Place the Anderson pin over the wire using a little stand there to hold it all together. I get my hydraulic crimper, place it over, and start the crimping process. Sometimes it's helpful to have another set of hands to help you with this. but I don't have that. So we keep on crimping until the die comes together, or you can't crimp anymore. We take the die off. Quick tip, if you add a little electrical tape to the wire and the connector, it'll keep it from moving around as you're trying to do this one-handed. With our pins crimped on, we go to our connector, and it's noted as positive and negative. So your red is your positive. So you want to make sure you insert that in the right spot. Otherwise, you'll get mismatched polarity, and that's really bad. Oh, by the way, you see the curved side on this? That goes with the curved side on the pin. The flat side of the pin is the flat side of the connector. So again, check your polarity, then you just shove these in there, and you'll hear a visible click once they're in there. We get a meter, we check continuity. So I'm on the negative side, which is this pin, and yes, there's continuity there. I go on to the positive side and then come over to the Anderson, and we have continuity, and there is no short between the wires. So we know this harness is working correctly. Now we're ready to plug in. So we go to the back of the Pecron, and we get our EcoFlow cables that we purchased, and we make the connections. These connections can only be made one way, so there's no chance of messing up the polarity. And then this end is going to plug into the EcoFlow, and there are two connectors back there, and I'm just going to take PV1. Now we plug our short harness into the Pecron. We mate the Anderson connectors, and you see this is positive and this is positive. It's the only way you can plug in. And they're mated. I won't close the fuse just yet because I'm going to turn on the vehicle first. In switching on the vehicle, I will make sure that the AC heating is off, that the console is off, and the headlights are off because they automatically come on, and everything is dimmed down to as low as possible. And I'm going to make sure all the interior bulbs are off. Now we hear that radio, and the radio's been switched off. So now there's really nothing drawing much power except for the electronics that just normally run. So now we can close the circuit breaker to the Pecron. So now I come to my circuit breaker, I engage it. So we have power coming to the Pecron. I switch on the Pecron. I get a blue light. If we go over to the EcoFlow, we should get a status. And we see that we're getting 500 watts with 1 hour to fully charge the battery pack, which is currently at 69%. We were able to achieve the 500 watts using the 13 volt setting for starting voltage. So during a power outage, we would literally use the power from the traction battery to run this Pecron, which is going to supply a higher output into the EcoFlow so we can charge that battery pack quicker, make that available for other uses like running the refrigerator or whatever we need in the house during the power outage. Then that frees up this vehicle to do one of two things, either for transportation, or we grab the DC to AC inverter and throw that on here and get power from the vehicle to run lighting and other appliances in the house. The Pecron has two fans, one on either side. make a little bit of a whining sound, but they help keep the unit cool. And that whining sound does go away. They run as needed to cool the unit. When I'm done charging the EcoFlow, I simply hit the power button on the Pecron, disconnect my harnesses so I can put this away, disconnect the Anderson. But first, I'm going to trip the circuit breaker, which I should have done before I disconnect it from there. And then that Velcro's there, and this goes with the rest of the Pecron setup, and this will sit in the side of the garage waiting for the day that we lose power. But isn't there a danger of draining the EV battery down? Well, even if it only had a partial charge, there's plenty of power for it to charge the EcoFlow. In the event that there wasn't that much power left in the EV, it would actually cycle off and prevent the EV battery from being fully drained. We also have the flexibility of going over to the Prius, which has the same Anderson connector to it. So we can plug the Pecron onto that. And since this runs on gasoline, but has a traction battery, we can draw off of that to charge our EcoFlow or to run appliances in our house with either car. So we have a fair amount of flexibility in the case of a power outage. This simple setup will allow you to recharge your EcoFlow regardless of the type of vehicle you got: EV, hybrid, gas, diesel. If you found this video interesting or useful, give us a thumbs up, leave us a comment, join the subscription team, and as always, thank you ever so much for watching.